Hi, today we're looking at section 5.6, which is dealing with confidence intervals. So we'll go through a few definitions to start things off, and we'll utilize those definitions to help us with a few examples. So first definition is a margin of error. So this is a possible difference between the estimate of a value you're trying to determine as determined from a random sample and the true value of a population of data. Now, usually this is represented by a plus or minus percent, such as plus or minus 5%. So for example, you might have something like a survey that determines how many people are likely to vote a particular way. You could have that survey say that they expect 55% of people to vote a particular way, plus or minus 5%. So that means that they could expect that could be 55 minus 5%, so 50%, all the way up to 55 plus 5%, so 60%. So it means that we can be 5% lower or above the middle value which I give. Now, confidence interval is simply when we take our margin of error and apply it. So if interval in which the true value that you are trying to determine is estimated to lie with a stated degree of probability. So our confidence interval may be expressed using plus or minus notation, such as 54% plus or minus 3%. So for example, from a survey, it's expected 54% of people will do something plus or minus 3%. That can also be rewritten as 51% to 57%. So this is our actual confidence interval, but plus or minus 3% is our margin of error, but writing it out with 54 plus or minus it, or it's spanning out to 51 to 57 would be our confidence interval. Confidence level is the likelihood that the result for the true population lies within the confidence interval. So even though, for example, they say that it's likely 51 to 57% of people will do a particular thing, they will all say they have a confidence level of something like 95%, which means 5% of the time it may be outside of that range. But 95% of the time it will be within that range. Okay, so we'll look at a couple examples. First example, a telephone survey of 600 randomly selected people was conducted in an urban area. The survey determined that 76% of people from 18 to 34 years of age have a social networking account. The results are accurate within plus or minus 4 percentage points, 19 times out of 20. For this survey, we want to state what our confidence interval is, what our margin of error is, and what the confidence level is. Okay, so probably the thing we should probably look at first is our margin of error. So we see plus or minus 4 percentage points. That would be our margin of error. So plus or minus 4%. Now our confidence interval is that and our original percentage. So 76 plus or minus 4%. So that's the same as 76 minus 4, so 72%. To 76 plus 4, so to 80%. Our confidence level is how often we expect it to be correct. So we expect it to be correct 19 times out of 20. That's 19 out of 20. We do that division, that gives us 0.95, which as a percentage would be 95% of the time. Okay, next example, a study of 500 Calgarian taxpayers revealed that 24.1% of these taxpayers made charitable contributions. The study was considered accurate to plus or minus 5%, 19 times out of 20. In a particular year, there are 827,120 taxpayers in Calgary. We want to know what is the confidence level, what is the confidence interval, and determine the projected range of the number of taxpayers making charitable donations. So first thing is, what is the confidence level? So that would be how often is accurate. So we've got 19 times out of 20. We've got 19 over 20, so that's 0.95. So that'd be 95% of the time. Confidence interval would be how much a population we expect to do something, and then integrate the plus or minus. So 24.1 minus 5% is 19.1. Percent 24.1 plus 5% is 29.1%. Okay, so now we want to figure out the actual range of people making charitable contributions. So what we'll do is we'll take the overall population and multiply it by each of these percentages as a decimal. So 827,120 times 0.191. And that gives us 157,979.92. So we're going to round that because it doesn't make sense to have part of a person paying taxes. So we'll round to nearest one. So that would be our lower amount. Our upper amount, we would just do the same thing, but multiply by our upper percentage. So that gives us 240,692. So writing that out, that'd be 157,980 to 240,692. Now we have this last question on here. If we were to use a larger survey sample, how would the results vary? So the more people that we survey, the more accurate our results are. So it can either reduce the margin of error, which will reduce the confidence interval.